In this tutorial, we will learn how to work with EXR images in SMODE. It is a type of HDR image, which means high dynamic range, meaning that these images can handle a broad range of brightness and color values, very useful for realistic lighting and effects. These images have deeper per pixel information. Here we will use 16-bit images, which are more interesting to manipulate than 8-bit images, for example. So we will start by creating a new compo, and in its settings, I will change the gamma value to sRGB instead of linear for more contrast. And for the pixel type, I will pick HDR 16 bits, as we will be working with 16-bit EXR images that are floating point, unlike 8-bit clamped images that are fixed values. So I will go ahead and select these settings, and then I will import EXR images, which are 3D renders that have been rendered using Octane. So I'm starting by importing this octagon image to explain a bit how EXR images work. Computer screens usually display 8 bits per pixel, which means that the red, green, and blue levels for each pixel is a value between 1 and 256, with 256 being the maximum value that can be encoded in 8 bits. So there are 256 possible values or shades, making it impossible to represent a color that would be brighter than white, with white being produced when the red, green, and blue values all reach 256. But with an HDR image, which, as we've seen, is of the high dynamic range type, it is possible to say that this white is brighter than another due to the floating point encoding system. What is encoded is the brightness value and where the decimal point is in the number. For example, a pixel can be 10,000 times brighter than another. Here, if I create a modifier of type exposure, if I raise this value, it will reveal all the information that was hidden in the picture, because the precision scale for each pixel is higher, allowing colors to go from very dark to very bright. Ultimately, computer screens, as we said, will only display images of 8 bits per pixel, but it's interesting to have a higher precision range for working with images, for example, compositing with SMODE. I just created a black uniform that I place behind the image, and I'm going to adjust the blending mode of this image to linear dodge, additive mode, and now I see that if I add the exposure modifier and set it to maximum, then lower the opacity of the image, I get an image that looks like the original. We can use this type of images to create interesting compositing effects. I will import a background image that is the same image but without the lighting. I will switch back to 100%, change the image gamma to 0.5 for more contrast, and I will reduce the exposure once more. On the background image, I will add a modifier of type color function, and within the function, we see that I can adjust the input levels for both white and black. So I'm going to raise the black level a little bit to around 15%. And I will also add a third image with a line of light like this. I will also change its blending mode to additive. And on this image, I will apply the modifier red, green, blue, RGB, and choose a red color like that. We can see that the lighting has changed to red. And I will also add another line of light, but this time at the bottom. Again, I set the blending mode to additive, and I will duplicate the RGB effect by pressing Ctrl and dragging and dropping onto the new image to duplicate the modifier. These two images, I will want to expose their opacity so that I can modify the opacity of both images at the same time with the same slider. So I will do a right click and choose Expose as percentage, which will create a parameter bank for me with the opacity of both images. And here, if I edit this function, I will invert the keyframes of the second image so that when one light is turned on, the other is turned off, and the other way around. I can add color labels to remember quickly that this parameter is linked to the opacity of these images. I am going to create an animation for this parameter by right-clicking and choosing a linear loop. But in the type of function, instead of having a linear ramp, I will look for a sinus to have the lights turned on one after the other, and I will accelerate the animation on 1 second. Another way to create animations is by using timelines. So if I go into the main timeline of my project, I can import, for example, my octagon image. I will change the compo duration to 4 seconds and the animation duration of this layer to 1 second. And I will tick fade out, which is also on 1 second, and we'll take the whole block. That will create this animation. And I can duplicate the same animation throughout the entire timeline. I will set the timeline to loop for continuous repetition, and so it will create a flashing effect from the light of the octagon. I can pause it. I am also going to import these 4 tube images, and I will import them all in my timeline with a duration of 1 second, with a fade out, and I can enable the snapping tool and slide them every second like this. They will therefore be displayed one after another. I can place them all in a pre-compo by right-clicking and choosing Make Compo to adjust their blending mode to linear dodge additive. And I can as well add a modifier exposure that we will set to 6 and change the gamma to 0.5 so that the lights are a little more intense. I will put the octagon to the foreground, and instead of animating its opacity, I will animate its exposure level on a duration of 1 second with a fade out. I will add the red, green, blue modifier on the pre-compo with the tubes as well. And I boost my animation speed by 3 for a more striking effect. In this way, we have seen that we can easily create light compositing effects in SMODE, animating them either locally or on the timeline. We could even switch on the different lights in real time using, for instance, a MIDI controller.